Okay, hello everyone. Let's look at the following problem. Again, we see that we have graph of velocity in respect to time, and as you can see, the slope is constant, and as I told you before, the slope is actually velocity. Okay. Now, if I want to calculate the velocity, we only need two coordinates, which in this case we can use this coordinate, final coordinate, and initial coordinate. Okay, to calculate acceleration in part 1. So we're gonna use this formula or expression for constant acceleration. Okay, the final point is 2 meters per second when the time equals to 0.5 seconds minus the negative velocity at time of 0 seconds, as you can see here. And finally, we can see that acceleration is positive because the slope also is positive. And we have this value, 12 meters per second square. Okay. Next question is what is the expression for velocity, the linear function of velocity, v of t. We're going to use this formula, okay, when we have to decide which coordinate we're going to use for to substitute t0 and v0. I choose the easy one. At time of 0 seconds, we see that velocity equals to minus 4 meters per second. And again, we're going to use calculated acceleration from previous part. And now we're going to use all these values and we'll substitute in this formula. And when we do so, we have this final expression for velocity, the linear function. Okay, next part, we need to find the function of position of object. Because we have acceleration, we're going to use this formula. And again, we need to choose t0, v0, and x0, which means, well, I'm not going to say initial. It's just we need to use a coordinate that is given or calculated by us. Okay, t0 I took 0 seconds. Now at this time the velocity is 4 meters minus 4 meters per second, and the position is 4 meters. And again, the acceleration is calculated before, which is 12 meters per second square. And again, we're gonna take all these values and we'll substitute in this formula. And when we do so, we have this formula, which is parabola. And if we see that coefficient of t squared is positive, which means the parabola would look happy and not sad at this time. And the next part, we need to draw, okay, this parabola. We need to see how it looks like. Okay, we know that initial velocity at time of 0 is minus 4 meters per second. And as I explained it in previous problem, the tangent of this function, okay, of parabola at any given time, it's actually instantaneous velocity, okay. So, or if you know, if you can to derive this function, okay, you will get that if you do this, okay, this is actually the velocity, which is 0 minus 4 plus 12t. But suppose we don't know that, but however, we need to understand that tangent of this function at any given time suppose 0 seconds, okay, it's actually instantaneous velocity at the same time of 0 seconds. So I cannot use, for example, this function because at time of 0 the instantaneous velocity should look like this: 0 meters per second, or the tangent of this parabola should be also 0. Now, okay, maybe it could look like this. Again, it is not, because the instantaneous velocity should look like this, probably plus 4 meters per second. So it's not good also. And if you use something like this, let's change a bit the parabola. Okay. Also, let's change the slope a bit. Suppose this is the initial position of 4 meters here, and the slope here will look something like this. The slope, or instantaneous slope or tangent of this parabola at time t equals 0 seconds would be minus 4, okay, meters per second. And that's how this graph should look like. Let's go to the next part. We need to calculate average velocity. Okay, the definition of average velocity is also given by delta x divided by delta t. Okay, now we know the initial time is 0 seconds and final time is 2 seconds. Of course, we will have to find the initial position of t equals 0 second and the final position of time equals 2 seconds. We're going to use expression that we found before, and we're going to substitute each time to find the position. Okay, now the initial position, it's when time equals to 0 seconds, we get 4 meters. And the second or final position when we substitute this function when t equals 2 seconds. And finally, you can calculate yourself to check if I correct or not. The final position is 20 meters. And finally, we can calculate the displacement. Displacement is delta x, when x final minus x initial gives us the value of 16 meters. Now we can calculate the velocity, the average velocity between 0 second and 2 seconds. Okay, and we get that the value is 8 meters per second. Okay, let's go to the next part number 6, sorry. Okay, we need to see how this value would look like in functions or graphs of x of t and v of t. Okay, first of all, let's look at x of t. We already more or less tried to draw this function before. Okay, what do I know? I know that the initial position of this object at time of 0 second equals 4 meters, and the final position at time of t, time of 2 seconds is 24 meters. Okay, and if I want to calculate the average velocity, it's actually this straight line, okay, from initial position to final position. And as you can see, the slope is defined by delta x, which is 24 minus 4, which will give you 20, divided by Um, Let me check this again. Oh, I'm sorry, it should be 20, not 24. Let's change this graph a bit. Something like this. Okay, also we'll take here and let's erase this point. Okay, now it's better. Okay, so delta x is 20 minus 4 equals 60 meters, and delta t, this value here, is 2 seconds. Okay, delta t equals 2 seconds, and if you want to calculate the slope, okay, which is in this case, it's average velocity, it will give you the value of 8 meters per second. It actually looks like, if you ask yourself something like, um, can I travel from initial time of 0 seconds to final time of 2 seconds, and I want to have the same displacement, but I want to travel with constant velocity. Okay, you can say that average velocity is something like constant velocity because the slope is constant. Okay, now how this value of average speed will look like at or in or on graph of v of t. Okay, this is the way that this graph, this is the initial graph, okay? However, if I want to add the average velocity to this graph, it will look something like this. You see that average velocity is constant, as I said before. Here also the slope is constant, and slope is velocity, average velocity. So that's why I can say that when I want to add average velocity to the graph of v of t, it should look like this. Okay, no acceleration. Okay, and if you try to calculate the area under average velocity, okay, I hope you know it's actually also displacement, in which in this case, if you try to calculate it, you will get that the value of displacement also 60 meters, as was calculated here. Now, interesting thing, if you calculate the displacement under the initial and true function of v of t, we will need to see that the value of the displacement should be also 60 meters. So if I want to calculate the area, it will be created from two areas. This one I will call it delta x1, and the second one, this one I will call delta x2, and then finally I add them. Okay, and I should get the final value of 60 meters. Okay, if I try to calculate the first area, okay, we need to understand that the height of this triangle, okay, is -4. Okay, so -4 times t0, this value. Now how can we find this value? We can use the function of v of t, and we can substitute velocity equals 0, which is actually what is going on at this time, and we get that this time equals to 1 divided by 3, or 0.333333 seconds. But I will use this expression. Okay, so the first area equals to -2 divided by 3. Second area is between t0 to 2, which means this area. Okay, so the base is 2 minus 1 divided by 3, and the height is 20. Let's use it. to find the area. Where is it? Where is it? Where is it? Here it is. Okay, this is the base. This is the base. Okay, this is the height divided by 2. Okay, and this is the expression for, or the value for the second area. Now we have to add them. Okay, you can see the addition here. Okay, some easy mathematical steps, and again, as I said before, we got the same value for displacement. Also, it's like to ask, okay, if I want to have the same displacement, which is area, like this, but I want to travel with constant velocity, okay, for the same interval of time, and I will get the same area. Just the area would be much more easier, which is base, it's 2 times average velocity, and I want to get the same displacement. Okay, well, I guess I can stop here, and I will see you in the next problems.